Good afternoon, everyone. Welcome to today's virtual brown bag session from the College of Engineering. We are so glad you are with us today. Today we have the Interim Executive Director and Director of Research of our UTA Research Institute. You'll hear it called UTARI. And Dr. Eileen Clements is going to tell us about what UTARI does and what UTARI is all about. I personally have a fondness for UTARI because back when it was ARI, I actually did my graduate research out at UTARI. So it's close to my heart, and I love to hear what they're currently up to. So I'm going to turn it over to Dr. Clements. She's going to give us an overview, and then we will have plenty of time for you to ask questions. So put your questions into the Q&A chat, and then we will moderate those and get those to Dr. Clements after her presentation. So Eileen, we look forward to hearing what you've got to tell us. Thank you.
Wonderful. Well, thank you so much for the introduction and inviting me to give the talk today. If you have any issues with hearing me or seeing the slides, just let me know. So I am Eileen Clements. I am the Director of Research at UTARI, as well as right now the Interim Executive Director. So just a little bit about me. I have my bachelor's in electrical engineering from the University of Cincinnati, my master's and Ph.D. in electrical engineering as well from Georgia Tech. I joined UT Arlington in 2007. I've been at the Research Institute the entire time. I came here as a faculty associate researcher, was a research scientist. My current position is the Director of Research, started that in 2012, and then took on the Interim Executive Director position as of last fall. So I want to introduce people to UTARI, and sometimes people don't really know where we are, and that we are off-site from the main campus. So first things first, here's a map. You are very familiar with where UT Arlington is in Arlington. And then there we are in Fort Worth off of 820. It's about a 20 to 30 minute drive depending on traffic, door to door. So at least now you have a little bit better idea of when we're talking about UTARI, that where we are. And there's our facilities. That's us. We are in a business park, the Riverbend Business Park. Across the street from us is actually a facility for the civil engineering department where they do pavement testing. So that's part of their research. This is our facility. We have a nice little lake there as well. So hopefully people who aren't familiar with us can come out and see us sometime. So what is UTARI, or who are we? So UTARI, and as Carter mentioned, we were originally the Automation and Robotics Research Institute, established in 1987. It was through a joint initiative with the City of Arlington, City of Fort Worth, UT Arlington, and the state. And the idea was to develop this institute that had a good tie with industry and the university. And so there was a building put up and developed, and the whole facility was brand new back in 1987, and that's where we've been ever since. We currently we've been operating out of the Office of Research for some time. So for those of you who may not necessarily understand what that means at a university, there's the academic side of the university. Under the provost, you have all your colleges and your schools. You have the College of Engineering, which has all the departments. And then outside of the academic side, you've got everything else at the university. You've got all the operations and human resources and business services. You also have the Office of Research. It oversees all the research activities at the university. And that's where we are. So UTARI reports up through the Vice President of Research. And we work with colleges and schools and faculty and students across the campus. Our focus is on applied research, and so I wanted to make sure we kind of touched on that, especially for students who may not be as familiar with research. If this is new to you, what that may mean. So there's basic research, which is typically more experimental. It's theoretical work that can be conducted to gain new knowledge or understanding of underlying phenomenon, observable facts. It may not have any particular application or use in mind. It may not. And then applied research is when that investigation is undertaken to acquire new knowledge, but it's also primarily directed towards a specific application, a practical aim, a specific objective. So at UTARI, we mostly focus on applied research. There's usually an application in mind, a specific objective. But research, basic to applied, there is a whole range. There's a continuum there. And so there are some things that we're looking at, or our researchers or faculty may be looking at, that may be a little bit more on the basic side, the fundamental side of understanding. But a lot of what we do really has some sort of application in mind. So we have full-time scientists and engineers here. In an academic department, you have faculty. Sometimes there are full-time researchers as well, postdocs and students. In our labs, we have folks who have their bachelor's or master's or PhDs in an engineering discipline, mostly engineers, some science disciplines, and they work on research full-time. They don't have a teaching requirement. Their job is to work on research projects, write proposals, meet with industry, do business development, not 24/7, but no, but 40 hours a week, essentially. That's their full-time job. We do also work with faculty, and so there's faculty who work with us in a joint capacity. They may have an appointment in an academic department and here at UTARI. And then there's other faculty who are affiliated with us. They work with us in some capacity, but they don't necessarily have an official appointment. And we have students. We do have lots of students who work out here. The full-time scientists are probably about 24 full-time scientists, probably about 8 or so faculty, and then students, I show a number there of over 40, depending on the semester, it could be 50, 60, it varies by semester, but we have a lot of students out here, undergraduate, graduate level, both. We also have a very big focus on strategic partnerships and developing those, whether it be by industry, especially since we look at applied research, making sure that we're focused on research and projects that are of interest and need to industry. We work with other academic institutions, government organizations, nonprofits, a whole variety. Why should you be interested in conducting research at UTA? I'll say in general, UTARI is just one part of the research going on at this university. There's so much. And I am going to borrow from UTA's undergraduate research office. We work with them in something, so I'm going to borrow this from them. This is on their website, where some of the reasons why you would want to conduct research. You can earn funding. You can get paid for the research that you're doing. You gain valuable learning experience, research mentorship, working with faculty, professional development, so more than just the technical skills. You get to add this to your career experience on your resume, really make you stand out, and network with faculty, staff, students. And so just kind of to emphasize that a little bit, you know, we provide real world projects that connect the classroom theory and teachings to the practical applications. It does give you an opportunity to develop these new skills outside of the classroom, whether it be teamwork and project planning, giving presentations, working against deadlines, things you do get in the classroom, but more so here. Hands-on experience that future employers really do look for, networking with other students and professionals. You can write technical papers. You may be able to become an author on a publication in a journal. You might get to give a presentation at a conference. You may even be able to be on a patent application. Lots of opportunities. You could also, especially working in applied research, I want to say that you could find something that you're very passionate about and that you decide that you want this to be your career, whether it be in academia as a faculty member or in industry. Perhaps you may even want to have a startup company on something that you're working on here. So lots of different opportunities. There's a link here to their undergraduate research website through UTA, so I encourage anyone who's interested in that to also take a look at them. What do we do here at UTARI? Why would you want to work at UTARI? We don't do everything, but we do have a few different research areas that we're currently focused on. We've been around for a long time, but that research focus tends to change over the years depending on the personnel that we have, depending on the needs of industry and government agencies, funding agencies. So these are what we're working on currently. Divided into about 4 different groups. We've got our Biomedical Technologies, developing devices for preventative care, wound healing, that type of stuff. Our Automation Intelligent Systems group, looking at robotics and unmanned systems. a sensor systems group looking at chronic health conditions, and then an institute within our organization called the Institute for Predictive Performance Methodology, mostly looking at composite materials and understanding composite structures and materials. So I'll go into each one of these in a little bit. We also have some really good lab facilities and capabilities here in our building that I showed you. We have 9 shared labs. Typically, they're broken out by topic area or what kind of work can be done in each one of those labs. Generally speaking, anyone who works out here could get access to any of those labs depending on what they needed to do. We have equipment for polymer processing and 3D printing, SLA printers, filament printers, paralink coaters, dip molding. For modeling and predicting performance of materials and structures, a lot of what the IPPM group does, they do both experimental and theoretical. So they will make composite structures and test them in-house with these systems, as well as then conduct or develop a lot of models. So using high-performance computing systems, machining systems for doing traditional machining, 4-axis CNC mills, laser cutters. We also have inspection equipment, SEMs, digital microscopes, profilometers, that type of thing. So first up is the Automation and Intelligent Systems Division. So they have a whole list of things that they have research going on in. Autonomous vehicles, both air, ground, mixed teams. They look at vehicle formation control, whether it involves swarms, leader-follower, mobility, obstacle avoidance, vision-based localization and mapping, target detection, classification. They have work in machine learning, human-vehicle interaction, augmented and virtual reality. We have a couple groups here working in that area, and also advanced manufacturing. So some of what they've got going on, for example, is their multi-agent, multi-system autonomy work. They've worked in developing optimal designs for assured performance of interactive multi-UAV systems. You can see some of this exampled here. The left video, you have a group of air vehicles. There we go. A group of air vehicles that are getting into formation, communicating with one another as a unit, so that multi-team aspect. Networked UAVs for lots of civilian applications, intelligent transportation, emergency response, and distributed search in urban environments using vision-based distribution formation control. A lot of research in the control area. The center video looking at both ground and air vehicle, where there's an air vehicle also communicating and coordinating how they are getting configured, optimizing their configuration to perform a common objective. And then the third video here on the right, looking at how somebody can interact with UAVs. There's multiple UAVs, but using more gesture control, so more of an intuitive interface for controlling those vehicles. Other things that this group is working on, UAVs for remote surveying, target detection and tracking. They have done research with fusion of both visible light and hyperspectral cameras. For example, this image on the left looking at a land area, looking at the vegetation growth. You could think of it for applications if there's drought, or looking at water usage, being able to identify healthy vegetation versus drought conditions, perhaps a water supply that's running low, or perhaps a leak in a water supply that you may not be able to notice it with traditional flying over the area or surveys. So being able to use UAVs in that regard. The center images looking at infrastructure inspection, the road inspection where you can fly a UAV over, or actually off to the side of the road, but still be able to collect the data and understand the topography of the road and surface characterizations, looking for defects or issues, but also being able to not do it directly over the road, so you can keep that road open and maintain traffic. Bridge inspections, if you have a bridge or other type of infrastructure that may not be safe or easy to get to, using the UAV to be able to access that. There's projects that we have with TxDOT, or have had with TxDOT and faculty at UTA working in this area. So there's real need for those types of services and capability. On the right, using UAVs, it says for high speed, high accuracy artificial neural networks for UAV-based identification of other UAVs. So you can imagine having a UAV being able to track or identify other UAVs. Is it something friendly, or is it an enemy type of system? both from above and below. So in this lower picture, there's actually a UAV out there. It's very hard to see. It's identified there, and the UAVs have been able to identify it and identify what model of UAV that is. So for identification and tracking. Other research going on in the AIS division, mixed and augmented reality for human-robot interaction. The video at the top is an augmented reality. You have, or mixed, you have the augmented on top of the actual natural environment where there's a robotic system, but using a virtual environment to be able to interact with that robot and control that robot. So developing capabilities to work with systems. We actually have we're looking for a student to work with us on this area in particular. I'll talk about that a little bit later. Machine learning, doing work in machine learning to classify landmarks. So simultaneous localization and mapping approaches. They build maps based on points, lines, or planes. But object detection can help SLAM incorporate semantics info into the map. So they've developed non-parametric statistical approach to solve the data between the detected objects over consecutive frames. There's a video of this actually getting generated as the system is moving around it. So they've done research in that area. Also printing on curved surfaces using 3D vision and adaptive control to print accurately on curved surfaces. And then other research going on in the area of assistive robotics for healthcare and aging. So a lot of different things going on in the AIS group. They also have, aside from the lab facilities that I previously mentioned, they've got additional capabilities and resources, a high bay lab space so they can do flying indoors, a Vicon motion capture system so they can actually monitor those systems and interact with those systems for indoor flight, lots of ground vehicles, air vehicles, other sensor packages that we can put on and off on different vehicles as needed. Also a service robotics lab that has a mock apartment with appliances. You can then test out different control capabilities and some of your research if you want to understand how robots can interface with that type of environment, especially for assistive applications. And 2 humanoid robots, both with mobile platforms, a PR2 and a Baxter robot that we use in various research activities. Next division is the Biomedical Technologies division. They have work, as I had mentioned briefly, in preventative care, rehabilitation, wound healing. They develop systems for these to address these areas. So there's a whole handful of things shown here. I'll show some videos on a few in particular. But the work that this team is focused in, the technologies that they use, a lot on soft robotics. In particular for soft robotics, using it because in healthcare applications, it provides more safety, more compliance when you're developing these systems that are going to be used in contact with an individual, especially for things like rehabilitation and preventing other injuries. They work also in control systems. They do finite element modeling, work a lot in fabricating using polymers. Then they also incorporate some VR and AR into some of their research. They have clinical partners all across the North Texas area, but also in other areas like Pittsburgh and Washington. And so the first one that I'm going to show you is a video on the seat cushion. So the seat cushion technology was developed for individuals who use wheelchairs, and the occurrence of pressure ulcers is a pretty significant factor for those who use wheelchairs, especially if they have limited lower body mobility. And you want to reduce the occurrence of pressure ulcers, and so one way to do it is to have a surface that can adjust and adapt. So in particular, this seat cushion can monitor where high pressure points are occurring and then offload that pressure onto other parts of the seat cushion. It can also, in this particular image, there's a high pressure point that's being noticed in one point. You can select that and have it completely redistribute the pressure off of the site that may already have a pressure ulcer forming and redistribute it to other across the rest of the seat cushion. So you want to reduce the occurrence or help in aiding in healing if a pressure ulcer has happened and not make it worse. Unique thing about this system is that it does not require a separate sensor pad to be used. The actuators themselves, which are using pneumatics, act as the sensor as well. So a lot of research in that in terms of the materials and the control aspect, the design, doing a lot of in simulation. These are actually real experimental data here. Another system from this group is the Reheal Glove, and in this, it's designed to be used for people who need who have severe hand injuries, such as like a burn on their hand. Traditionally, when you treat a burn injury of the hand, you're going to wrap it up, and that's going to really restrict the movement of it and your ability to view how the wound is healing. So in this case, creating a transparent, flexible wound healing device that somebody can wear. This is an older version. They've been continually working on this with a clinical partner, adapting how you actually attach it. But it has the ability to pull a negative pressure, which is used in wound healing processes. And then you can also allow for movement so that the hand doesn't form contracture and you're not going to have limited functionality afterwards. So it's another project in that group. And then a final video from this group is their Rehab Glove, another glove, but not for wound healing. This would be for rehabilitation. So in this case, you have a glove that somebody would wear, and each of these actuators is on a digit, and it can bend, and it can control the bending of each digit in multiple locations. It's all pneumatic based, so again, looking at the soft robotic side of it to provide safety and compliance for somebody as opposed to a rigid mechanical actuator system for rehabilitation. This can help assist in somebody trying to gain strength. It can measure strength, it can measure range of motion, so it can be used to provide that data back to a clinician as well. So the soft robotic side of it, the polymer development, the control aspect of it, a lot of ergonomic design to also think about in here, and that's actually gotten us partnerships with folks across in other departments across the campus who have some work going on in that area. Other research that this team has been looking at, a prosthetic line, a liner for a prosthetic interface, so a dynamic liner that can adjust the fit in real time and help if there's slippage, help if the volume of the residual limb changes throughout a day or from day to day. And then also now taking that same technology and putting it into a shoe, and for a shoe insole to prevent diabetic foot ulcer occurrence on the foot. The next group is a sensor systems group. Not as just a couple of projects going on in this group right now. The first has to do with PAP therapy, positive airway pressure therapy. If somebody has been diagnosed with sleep apnea, most likely the treatment that has been prescribed has been use of PAP therapy to keep their airway open throughout the night while they're sleeping. A big issue with using PAP therapy is adherence, that you want users to understand how best to use their PAP machine, but it's hard to do while somebody's sleeping at night. So working on a system, both hardware and software, that can monitor the use of the PAP system in real time and provide automated feedback to the user so that they can best understand how they're using it, if they're having trouble using it, to get the best behavioral treatment to them in real time, as opposed to a human therapist or behavioral intervention specialist who you'd have to see during the day when you're not asleep, or you'd have to wait a month, 2 months, 3 months before you actually see those specialists. So something real time in the home. Other work in this group is looking at more of data analysis side of things when it comes to wearable devices and how the data in those wearable devices can be used to provide personalized, adaptable, timely interventions. Also looking at the behavioral side of interventions in order to help people. Maybe it's with weight or diet to help treat either it could help treat some chronic conditions, or it could be used for individuals who may have, there's a project going on with folks who have cancer, but looking at how you can help them in their everyday behavior to have a better healthy life, and working with faculty on that project in kinesiology, so across other departments across the campus. The last group that I'll touch on, the Institute for Predictive Performance Methodology. So they're a little bit, the folks in that group are a little bit different than the full-time research staff. They do have quite a few full-time research staff, but they also have faculty. So in this particular group, there's a whole list of faculty here. You can see the list there that are both appointed in an academic department as well as here at UTARI and conducting their research here. So this group, their vision is to reduce the cost in the conception, development, and application of engineered materials and structures and the risk of using them in society. Their approach to do this, predictive performance based on operational observables and knowledge-based models to reduce the development and maintenance cost. And then their focus is in engineering, heterogeneous composite materials, been used in a variety of application areas. Each one of these faculty has a slightly different research area that they're focused on. The director of IPPM is Professor Endel Ayarve. He's in the Mechanical and Aerospace Engineering Department with a focus in discrete and damage modeling. Professor Ken Reefsnyder is also an MAE. He's the founding director of IPPM, and his focus is in strength and life prediction. Professor Russell Rehan, also an MAE, working in the area of methods for multi-scale manufacturing. Professor Ye Sao in the Material Science and Engineering Department, mesoscale modeling of microstructures and materials. And then Professor Hin Liu in Industrial and Manufacturing Systems Engineering, looking at multi-scale modeling. So a lot of different work. I'll touch on a couple of efforts that they have ongoing right now. One of the big areas that they're looking at is using dielectric properties for material performance prediction. So if you can use the dielectric properties of a material, of a composite material, to identify when that material is going to fail or need maintenance, rather than doing a destructive investigation of that material, that can help with cost, it can help in performance, reduce or improve how often systems and parts are going for maintenance. One area is looking at in situ damage evaluation. So the images on the left, looking at actually making the composite samples in-house using the equipment that I talked about before, and then putting them on mechanical testing systems and identifying when damage is occurring, and then correlating that with their dielectric properties using other systems that we have. And then putting all that data into models to then be able to predict when systems are going to fail or have certain damage using that dielectric information. Other work using also dielectric properties, doing quality monitoring of raw materials. So if you think of a composite material, the pre-preg material, it could sit on a shelf for quite some time before it's actually going to be used. You want to have less waste, but how do you know how that material is going to perform if it's past a if it's had a very long time before since it's been manufactured? So can we look at those systems, and as they age, what are the properties of them, do the mechanical testing and correlate that with the dielectric properties, and also put that into modeling. They also look at adhesive bond strength, and in fact the next video is going to be of a student who worked here, the work that they did as part of an REU experience in the IPPM UTARI group. And in fact, this project was put forward a couple years ago for the College of Engineering Innovation Day, and it won first place for REU projects. So I'll let this video play. She'll talk about her research project and the data collection results.
I'm an undergraduate freshman at University of Texas at Arlington. I'm going to present my REU project on adhesive bond strength assessment of composite materials. This team project was done along with another undergraduate student, Eileen.
Nowadays, composite materials are being applied in every aircraft and automotive to make them lightweight and fuel efficient. In these structures, the composite parts are still being bonded and joined using metal bonds and fasteners, which add weight to the structures and act as potential crack or damage initiation sites. Adhesive bonding is a proper substitution to this problem, but adhesive bonds are not fully reliable and their failure is difficult to predict. The goal of this research undertaking is to investigate how different kinds of contaminants and defects weaken the adhesive bonds and how this kind of weak bonds be detected by measuring the electrical and mechanical properties. Based on different design and strength requirements, adhesive bonds can be chosen from a broad range of types, among which flap shear, scurf joints are dominant. So we are proposing two technologies to predict bond strength of composites. Using broadband dielectric spectroscopy apparatus, we execute a frequency sweep between 1 MHz to 0.1 Hz and measure the permittivity of the specimen. We can execute this frequency sweep over our range of temperature. This information allows us to assess material state. In the thermally stimulated dielectric current, we can measure the depolarization current of the test specimens, which provides more information about the material state. Now about the experimental approach. We utilized compression molding to make fiber-reinforced laminates from pre-packed materials. Test samples were made by cutting these laminates and bonding them using film adhesives. Using the Cross Mobile Surface Analyzer, we measured laminate surface vitality and surface free energy. This gives us an understanding about the affinity of the surface, that is, whether the surface is hydrophobic or hydrophilic. For test batch 1, different categories of samples using 6 different types of surface modifications were prepared. We used them for dielectric property measurements. The results are promising, and we found that the dielectric properties can be used to assess bond quality non-destructively. In test batch 2, we wanted to investigate correlations between the dielectric property with the mechanical strength. We measured the dielectric properties of different samples with different surface modification and measured the shear strength of the lab shear specimens destructively and established correlations between the mechanical and dielectric property.
This is the NTS chemical testing instance, and we are performing a mechanical test to determine the lab shear strength of the adhesive bond in the composite material.
For test batch 3, as we verified that we can assess the bond quality with BBDS and TSTC, we wanted to find out with controlled contamination how the dielectric property changes with the varying amount of contaminations. We made samples with varied concentrations of contaminants and carried out BBDS and TSTC experiments and observed a trend of increasing dielectric properties at different temperatures. With our experiments, we have verified that we can non-destructively assess bond strength using the dielectric properties. Further experiments on different types of adhesively bonded composite materials are required to fully establish and substantiate this assessment method of adhesive bond assessment. The approach taken in this project to assess composite adhesive bonds has advantage over conventional non-destructive assessment methods, as it is not too affected by the complexity from the heterogeneity of composite materials and signal attenuation. Further developing of the method described here, we will be able to improve the reliability of adhesive bonds and composites.
I want to thank our RU program, Department of Mechanical and Aerospace Engineering, UTARI, Institute of Predictive Performance Methodologies for giving me this amazing opportunity to work with professional researchers and dedicated mentors.
And I thank them for also putting that video together. That's a great example of the type of research that the students here are involved in. So, all of that research activity, you know where we are, this is the type of work that we're doing, so how do you get involved? We have both graduate and undergraduate students who come out here each semester. Right now for this spring, it's over 20 students who are returning, so they've been here before and they're coming back, as well as over 20 who are new that haven't been out here before, and we're able to have new opportunities and for them to come out and work here. The students either are working under a supervisor who is a full-time research scientist here, or it could be one of the faculty who work out here. There's also instances where we have a partnership between a faculty who's not necessarily affiliated with UTARI and one of our researchers, and the student works together. So there's a collaborative project going on, and that student is able to work both for that faculty and get experience here at UTARI. Again, the benefits of it, the hands-on experience with real-world problems we've talked about, and connecting the future workforce to potential employers. Some of the projects that the students are working on are sponsored projects from industry, or they're a project that industry is involved in. So you're getting a direct connection with a potential industry employer in the future. Every semester we put out an online application on our website, and I thank the college for helping to circulate that each and every semester when we put that out. There's a link there to our website as to where that will show up. Right now, what's on there, it's not open at the moment. Our next session will open for summer 2022 students, and that should open or sometime probably in the next 3 to 4 weeks. We don't have that date set just yet, but be on the lookout for an email that'll come out from that, or you can check our website. Right now, what's up there are example projects that we've had posted in the past, so you can get a sense of what the projects may be. Sometimes they're the same ones that are put out for the next semester, so you can get a sense of what those are. And then we also have periodic announcements that we may send out for off cycle, off of this every semester cycle, that will also circulate through the College of Engineering. Most recently, we had one on AR/VR technologies. And that one we sent out to a targeted audience of students that we believe will have the skill sets that we're looking for in there. And I think for that, we look for students in computer science, electrical, and mechanical, I believe. Of course, there could be students in other departments that also have interest or skills associated with that. So if you're interested and you didn't see that, you can always reach out and we'll get you connected. There's a picture of our summer students from 2019 out here looking out over the lake when we got that picture. That's why everyone's smiling. And just to highlight again, these are some former UTARI research assistants that over the years we have quite a few. There's a lot that have worked out here before, and I've pulled just a few just to show where they are now and the opportunities that they have. The individual working as an engineer at PACCAR in Seattle, an engineer at Novo Engineering in California, research scientist looking at artificial intelligence out of Ford Greenfield Labs in Stanford, an engineer here in Arlington at Spectral MD, one of our own, so a student who was at UTA, worked here as a research assistant, and then came on and worked here at UTARI, is still here now as a full-time research scientist. We actually have a few of those here. And then another who's working as a patent examiner at the USPTO here in the area. So a variety of opportunities are available to these individuals. And we've heard different stories here and there that their experience here at UTARI, and we know this is true even if you're not working at UTARI, if you're just getting research experience, that it does help you stand out from the rest of the applicants. And that experience is extremely valuable. Here's our contact information. There's our website. All of us, all the people who work out here at UTARI are on the website with our emails, so you can look through and you can check out the different research divisions and the personnel there. That's our address, again, located in Fort Worth. And then that link for the research assistant opportunity. So that is what I wanted to share with you today. We hope you look into us a little bit more, and if not UTARI, other research opportunities throughout UTA. They're very worthwhile.
Thank you so much, Eileen. In our questions that came up from the students, they were all about how do they get involved. So you gave them exactly what they needed to know about how to get involved in your research. Now, I do have one student who had a little bit more detailed question, and I'm going to pose it to you, and then you can see how you would address the student's concerns. So in particular, this question says, how can undergrad students with no prior research experience get started with research? Their comment says, research seems interesting, but at the same time, daunting.
Oh, it's a very good point. And first, I think it's good that you're thinking about it, just even posing that question and recognizing that it can be a whole world that just seems very unfamiliar. Like you already have to have a lot of knowledge before you even are able to get into it. I think a very important aspect is to reach out and talk to people, have some conversations. You have a huge university at your disposal here, lots of faculty who are willing to talk to you, research scientists who are willing to talk to you. You just have set up a meeting with somebody and talk to them about what is the research you're doing, what does it mean to be involved in research for them. I would suggest look around at the websites of different research pages, learn about the projects that they're doing. You may not fully understand all of the project that they're putting out there, but find something that at least looks interesting to you and look a little bit more into those. And those are the folks I would suggest reaching out to. One thing that we do get a lot of applicants, we do, and it can be hard sometimes to find the right person that you want for your project. But if somebody looks at our whole list of projects and they pick out just a couple, not the whole list, we have people who apply to everything. If there's somebody who applies to just a couple of things and tell us why are you interested in that? Why do you think you have some skills that could be useful to that project? Maybe you're early on in your college career here, so maybe you haven't taken all the classes, but there might be something in your past or in your experience that you can apply to this. Tell us that. We ask for a resume as well as a statement of interest. I appreciate the statements of interest. I appreciate hearing from students as to why are they interested in this? What can they bring to the project? And persevere. You may not get selected the first time around, but keep trying or keep reaching out to people to have conversations and find that right fit. You may also be able to talk to some of your colleagues, some of the other students around who may have some research experience, and they can give you their own take on it. Who was good to work with, who was a bit of a struggle, which group did they feel like they got a great experience out of. Go talk to them. And I hope that answers some of what they're looking for.
Yep, that's great. And that I'm going to just reiterate, students, the connection and the communication is very key. You have to be willing to put yourself out there. So a faculty member, you might be a terrific fit, but if the faculty member doesn't know you and you don't reach out, there's no way that's going to come together. Okay, so you have to do your part and go look. As Dr. Clements said, it makes sense to do some research before you start asking. And this is the kind of research you know how to do for a paper, right? You go on the websites, you read about what they're interested in. Maybe you go then look at other more broad things and just say, okay, I need to know more about rehabilitation so I can understand more about this Reheal Glove, right? So do your background before you go talk to this faculty member or write your statement of interest, because that shows that you really are putting yourself into this. And that shows some commitment and some persistence, which is also going to be a benefit to you in looking at these opportunities. And as Dr. Clements said, don't give up if you don't get the first opportunity. Okay, you have to keep trying.
Yeah, great points.
So I didn't see any other student questions yet. Hey, there we go. There's a new student question. Oh, now there's a couple more. Okay. Let me back up and look at some of these earlier ones. Some of these questions are about scheduling. And does UTARI work with your class schedule and things like that? And I'm going to assume that's a yes, because UTARI knows you guys are students. That's kind of an obvious.
Of course. But I mean, I understand that can be a concern, but just have that conversation. If you get to the point where you're talking to a potential supervisor about a project, just be upfront about what your class load is. How many hours do you really think you're going to be able to put in? We don't want to compromise anyone's academic career, so be honest about how much time you think you can put into something. If you really don't have a lot of hours to spend, coming all the way out to UTARI to do something may not be the best use of your time. As you saw, we are located off-site.
Right.
So in order to get into a research project, it can take some time. It can take some, 10 hours a week, minimum, as if somebody has that they can put in to really get into a project and be able to get something out of it for you and be useful for us.
Yep. So I do now see a number of questions. So does the student's major have to match the area of research that they're interested in?
Not necessarily. If you have the right skills and you can do the work, we do not have a preference then that you're in a particular discipline. We typically are going to look for somebody in a certain discipline just based on our understanding of the skill sets that are required. But there's people out there who have tremendous hobbies that go well beyond what academic department they're in. So we're not going to discount that.
Got it. So one question asks, and this is certainly a COVID question, are there opportunities for research with UTARI that are conducted remotely?
Yes, there are. A lot of the things that we do are hands-on, so there are limits to that. But at the same time, a lot of the stuff we do can be done on a computer, and we can remote in. And so we do have some students who are working remotely. And in fact, I think we've had some start their work here at UTARI being remote, where they really haven't had to come on site for very much. It just depends on the project. So if it's something where there's lab work, there's no getting around that. You have to be in the lab making a device, making a system, collecting data. There's no way around that. But if you're doing more modeling or simulation, programming, maybe that's stuff that you can do more remote.
Okay. So there's a couple of questions about summer and fall positions. You mentioned summer positions would be posted in the February-March timeframe. Okay, so students will just need to look out for that. What kind of schedule do you use for posting fall positions?
Summer is so let's say something first. When we post the positions, they're typically out there for 3 to 4 weeks. Then we close it. And then that's when we're doing all of our internal process where we're reviewing applicants. Hopefully we're reviewing applicants all the way at the start when they start submitting applications, but we don't finish all of our processes until the application is closed. Everyone's had a chance to review people, interview people, make those connections. So it takes a little bit of time. So for the summer, we try to do a similar thing, but the summer is so short. The timing for it's a very quick turnaround. And so we will open our application probably towards the end of June, right around that time frame. But the application during the summer for the fall is typically open for a shorter period of time. So you really have to be on the lookout for that one and get it in there soon. There's always circumstances that we have to look at things and outside of that schedule, but we really try to get most things, 99% of the applicants all through that standard process. So that's generally the timing.
So related to that, are the research positions year-round or are they semester-based?
That depends on the project. A lot of our projects, they are continual. There's going to be the same type of effort that we want done the following semester, but that just depends on the projects, and every project is on a different schedule. So one may be ending where one's continuing, a new one is starting. They all vary. I will say, and this is where I hope people don't get discouraged. We do have returning students, which is fantastic for us, but we can't always count on that. And so we are looking for new applicants and new candidates. So sometimes you may not be able to get in for that project that you wanted because maybe there's somebody who's returning for it, but hang in there. Maybe there's another project that may be of interest. The other thing I would say is some of our students are paid, that there's funding for that project. Some of our students are not, and they are here in a volunteer capacity. I know and understand not everyone is in a position to be able to do that. But if you are, then we try to provide a volunteer experience for individuals when there's a project that they can look at and they have some time to put on it.
And I'm assuming typically students who volunteer could be getting independent study credit or graduate or undergrad research credit potentially.
Potentially, and I think that's something that for us working with the college, that is certainly something that we would like to look at and help if there's a way that we can do that. Since we're not an academic department, there's other ways that we would have to look into it, but certainly right. We'd be happy to try to do that.
Right. So another question, does UTARI sponsor undergrad senior design projects that can assist you all in what you're doing?
Not all the time. There have been some instances in the past. That depends on our researchers and faculty if they have a project that they want to put towards a senior design. I will say we haven't done it a lot, and I think typically that's because a lot of the projects that we have, there's a certain schedule around them that we are trying to maintain, and the senior design schedule doesn't always assist with that schedule. So we don't have a lot of that, and in fact, I'm trying to think of the last time that we had one, and it might have been a couple of years now, but I don't quote me on that, but it's definitely not something we do a lot of.
Okay. All right. I think I'm caught up on the questions. Let me check. My screen, my questions don't seem to be refreshing entirely. So
let me add something that just in case, if somebody does reach out, do some homework first, like we suggested. So when you're reaching out, you have something to say to that individual. Sometimes our researchers or the faculty may not get back to you right away. You may want to try again if you can. Some just wait for the postings to go out and just want people to respond to those postings. So don't be surprised if you may get a response like that of just go ahead and apply. If you do that, what I would suggest is you can also reach out and say, hey, I applied, but make sure you submit that statement of interest too through the application process so that you can express your interest and your background there, that those are looked at and they can be useful.
Okay. We only have a couple of minutes left. Let me ask just a couple of questions. How does UTARI decide what projects to work on?
They are researchers and faculty, since their jobs are to be focused on research projects. Part of it is where's the funding coming from. So if they're writing a proposal to a funding agency, maybe it's a Department of Defense agency, maybe it is an NSF or an NIH, then those projects if they're awarded, then we have those projects to work on. We have those specific things. We try to stay in tune with what the needs of industry are, where technology is going, what types of advanced systems we should be working on. And so we're trying to make sure we're working on things and developing technology that is useful to industry and to the customer. So we're looking at funding announcements, we're talking to industry, we do a lot of business development. I mean, this is the non-engineering side of things, right? This is actually getting out there, meeting people who work at companies, what are their needs, so that we can make sure we're focused on things that are meeting their needs.
Excellent. So which comes first, the project before the funding, or the funding leading to the project?
Boy, I wish the funding always came first, but that doesn't typically happen. We have to be on the lookout of where are funding agencies going. You look at, there's lots of reports that come out from funding agencies about where their focus is going to be, what are their 5-year plans, their 10-year plans, what are the interests of, especially the Department of Defense. For us, that's a very big area that we look at. What are their needs for their soldiers, for their systems, their advanced systems? What are the technologies that they're really going to be focused on? And making sure we're staying up to date on that. Our researchers, just like everyone in research, faculty, have to stay up to date on the latest technologies and the latest developments. You have to be aware what's getting presented at conferences, what are in the journals, what are different entities working on, and staying aware of what the needs are of those customers. So if we have funding, that's great. If not, we're trying to work on things that are going to prepare us for that funding, that are going to position us to be awarded that funding. So doing preliminary work, preliminary studies, getting early data so that we can show to somebody, this is a good idea. We think this meets your needs based on this information you have out. Now would you please provide us more funding so that we can take it to the next level? So we'll write proposals, develop those relationships, and then look forward to that funding coming in.
Excellent. So we're caught up to date on the students. Anything else that you want to share with us about UTARI? What about opportunities for training, or how other things that UTARI might have going on that students could have the opportunity to maybe just come visit?
You know, that's a good point. We have a seminar series. Lots of departments, I think, have seminar series. We do as well. So we do try to have it's a once a month seminar, typically on the last Friday of the month, but it can vary depending on schedules. We'll either have people speaking from UTARI, so it could be one of our researchers talking about their work. We invite faculty to come and give talks as well, or we sometimes reach outside of UTA and look for guest speakers from other universities or industry to give talks. So we try to post those on our website, and then thank you also to Jeremy and the college for helping to circulate that information. So be on the lookout for those. That could be an opportunity to hear what we're talking about. I would say, especially if there's a UTARI person giving a talk, that could be a really good way to learn more about the research, and that could give you a very good opening too. You could attend the talk, ask questions, reach out after saying that you heard them give a talk and you wanted to follow up. That could be a very good way to start that dialogue. We currently don't have any workshops planned at this moment, but we do periodically look at developing workshops in different technology areas. So if we do those, they would always be put up on our website.
Excellent. So I think we're about out of time. Gives the students time to get to their 1 o'clock classes.
Grab a bite.
That's right. All right. Anything else you can think of that you want to share with us?
I don't have anything else to add. I just say thank you. Thank you for giving me the opportunity to talk. We hear a lot about people not knowing who UTARI is, or that we even are part of the university. So any opportunity that we have to spread the word and let people know about who we are and what we're doing, appreciate having that opportunity.
Fantastic. And I know that folks from UTARI also come out sometimes and talk to people here on campus too. So for you audience, I was telling Eileen that I actually had lunch with one of the UTARI research scientists on Friday, who was a former student who's now working full-time as a research scientist. So there are lots of ways to find people at UTARI if that's something that you're interested in. So Eileen, thank you so much for taking the time today. We really appreciate it. Certainly, students, you are able to go look at this information, use it to make contacts. You can contact me if you need further information, and I'll pass it on to the right people. Thank you so much for taking your time today to join us for this virtual brown bag. The schedule for the virtual brown bags is posted, so you can take a look at all of the scheduled activities that'll be coming up. They're typically on Wednesdays and Fridays at noon. So we hope you will join us for other activities throughout the semester. And thank you again. We are done for the day.